In this video, we're going to look at some more complicated examples of using combinations. And we've got two things to recall here. Our permutations, or where the order matters. We use NPR is equal to n factorial over n minus r factorial. In our combinations, where the order doesn't matter, we would have n choose r is equal to n factorial over n minus r factorial times r factorial. In example 1, we've got a committee of students and teachers is being formed to study school issues. 15 teachers and 18 students have volunteered. What we want to know is in how many ways can a 5-person committee be formed. So the first one we're going to look at is no restrictions. So our number of groups, we'll call it in total. Now the order doesn't matter here, so we're going to use our combinations. Evaluating that on your calculator will give you 237,336 possibilities. Now the second one that we're going to look at is what if we want the group to have 3 students and 2 teachers. So we've got 3 students and 2 teachers. So what we need is to look at the possibilities of choosing 3 students, so 18 students, choosing 3, and we're going to multiply by the number of ways that we can choose 2 teachers. 15 teachers choosing 2, we would get 816 times 105, and then we would get 85,680 possibilities with 3 students and 2 teachers. The next one, choosing a committee that is made up entirely of students. We would only be choosing 5 students from the group of 18, which would give us 8,568. Now the next one that we're going to look at is if the committee has at least 1 teacher. So let's set this up here. So if we've got at least 1 teacher, we would have the situation where we've got 4 students and 1 teacher. We would have to add the situation where we have 3 students and 2 teachers, plus the situation where we've got 2 students and 3 teachers, plus the situation where we have 1 student and 4 teachers, plus the situation where we've got 5 teachers. Now that is a lot to calculate and can get kind of cumbersome. What we want to use here is the indirect method, where we're going to take our total and subtract the complement. Okay, so our NA, so this is what we're looking for, at least 1 teacher, is going to be equal to our number of our total possible combinations, which we had in group 1, and we are going to take away the complement, so all the groups that don't have at least 1 teacher. So this would be our group where we have all students, which we've actually already calculated, and the situation that's it. So we're going to take away our number where we have all students, because all of the other groups are going to have at least 1 teacher. So here, our total we calculated before from part A. So we've got 237,336, and we're going to take away our answer for C, which is the number of groups that are made entirely of students. Subtracting those is going to give us the number of possibilities where the groups have at least 1 teacher. So it's not wrong to do it the other way by adding up all the possibilities like I did here. It is more work that you have to figure out. If you want to test it, you can figure out the number using this method 1 up here and compare it to the answer where we have at least one teacher. Okay. Let's look at another example here where we're going to use our indirect method. So in how many ways can 5 people be selected from a group that consists of 5 adults and 10 children if the group must have at least 2 adults? Okay, so we need at least 2A. We'll use A for adults. So we could have the groups 2 adults and 3 children. We could have 3 adults, 2 children. We could have 4 adults and 1 child, or we could have 5 adults. So we could add those all up, or we can use the indirect method by subtracting the complement. So here, our group of at least 2 adults would be equal to our total number of groups, subtract the number of groups with all children, and the number of groups with 1 adult and 4 children. So in order to figure that out, we would have our total number of groups would be 15 people, choose 5, subtract the number that is all children, so that would be 10, choose 5, and then the number where there is 1 adult and 4 children, we would have 5, choose 1, which gets us our 1 adult, and we're going to multiply by the number of children that we're choosing. So 10, choose 4 to give us our group of 5 people. Evaluating those is going to give us 1,701. Before we do our last example, we're going to do a little bit more factorial practice. So if you remember before, we want to be able to write it so that the same factorial is on the top as is on the bottom. So the top only has n factorial, so I'm going to expand that out until I get the same factorial on the top and on the bottom. That's going to allow me to cancel, leaving me with n. Same thing here. I'm going to notice that my factorial on the top is higher in the sense I don't have as much subtracted. So I'm going to subtract until I get to the same factorial on the bottom. That's going to allow me to cancel out, which leaves me with a minus 1, a minus 2. And my last example here, we've got 3n times 3n minus 1 factorial, which is the same factorial that I have on the bottom. That allows me to cancel out those 2 numbers, leaving me with 3n. Being able to simplify factorials is helpful if you are not using the NCR button on your calculator. It allows you to simplify numbers a little bit. Okay. Last one we're going to do is to determine the number of ways of selecting 2 boys or 2 girls from a group of 4 boys and 5 girls. So anytime you see or, you want to think about adding. And so what we want is the number of ways that we can choose 2 boys. So we've got 4 boys and we want to choose 2 of them, which is 6 ways. And we also want to know the number of ways that we can choose 2 girls. So we've got 5 girls and we're choosing 2. So 10 possibilities there. To get our total, we're going to add those 2 together. 6 plus 10, which is going to give us 16 ways of choosing 2 boys or 2 girls. If the question had said 2 boys and 2 girls, we would have multiplied 6 and 10 together to get 60 instead.